Now I'm unmuted, right? Okay, so thank you very much for having me today. And I have to very much apologize for me being late. Today at 4 p.m. we suddenly got a phone call from our vet, our Tierarzt. We had the blood of our cat done there today, and she told us, get into the car and drive to the nearest animal hospital immediately. So that was the reason why my wife and I immediately postponed. I hope for your understanding. The cat is fine, more or less. My wife is now feeding her everything she would ever like to eat, so she's kind of in cat heaven. Let's see. I think she will be fine. Maybe I will get a WhatsApp message with a cute cat image today during the talk, then I will show you that she's really fine. Okay, my topic today is everything about C#. You know, ref, the keyword ref is a pretty old keyword. I'm pretty sure everybody here in the room who is able of writing C# code knows what ref is in terms of parameters. If not, you will hear today. But ref is the hidden superstar in C# for the last years. Most people don't know or don't ever see ref in conjunction with structs, for instance, but trust me, ref structs are the magic sauce that make C# and .NET really fast. And I will tell you why and how. But before we go into any details, let's quickly repeat the basics, okay? I'm pretty sure everybody knows that. We can make a static function, for instance, something like do something, exactly, and cursor is immediately suggesting something. Everybody knows this one, right? Ref int. Normally, we pass structs by value. By adding the ref, we pass a pointer so we can manipulate the value of x inside the function. Everybody's fine with that, right? So if I quickly change or set the value and print it out, let's go here. Let's define a variable, let's call it I with a value 10, then call do something, give it the ref of I, and then print the I, and I'm pretty sure everybody will understand if I call .NET run, the result will be 15, obviously, because we pass a ref parameter. Just a quick reminder. Also, quick reminder, if you have a ref parameter, the caller and the callee have to both agree to using ref. So the caller has to say, okay, I'm sending a pointer, and the callee has to say, okay, I'm receiving the pointer. So both need to say ref and we are fine. This is just a pointer, nothing special. Any questions? Why should anybody do that? I mean, why do we do that? Yeah?
Adding flags to a flag
something like this. That could be.
User and the enum is a
That's definitely a thing. Sometimes we simply want to be able to change the content of the variable. Sometimes we simply want to do that. Another extension methods, okay.
Really beautiful with an extension method.
Okay. I don't have an example for that, but sounds interesting. Another option why you typically do that is if you have larger structs. So imagine that you create a record struct. Let's call it a large struct, something like this, and then put in 4 integers, for instance. So if we define up here an instance of this large struct, and if we change the do something here by adding a ref large struct, maybe change that one, we can add it here, and now we do no longer pass by value 4 integer values, but we only pass a single pointer, right? So that is an option that we can do. Absolutely, we can absolutely do that. What we can't do, at least what they couldn't do, at least in former versions of C#, is using those ref parameters together with enumerators and yield statements and async and so on. We will definitely take a look what has changed there. Okay, I think we are pretty good. I think this is fine. Let me add another example here and change that a little bit. Oh, get rid of that. If we define a method, let's call readRef, and we say ref read only int x, and the ref read only read only, and then define our large struct again. We had a record struct, exactly that one, ref read only, large struct, this one. It doesn't matter what we do here, just imagine any kind of thing here. Now here we have a ref and a read only, and I'm pretty sure that not everybody in this room knew that this existed. At least whenever I talk to people and do trainings in C#, many people know ref, but some people do not know that there is a ref read only. And that again goes into the same ballpark as this large struct thingy, because sometimes I want to speed up things by not having to copy large structs over the stack, but I still don't want the callee to be able to change my struct. And by defining it as ref read only, we get the advantage of passing a pointer without having the disadvantage that the callee can change the content of this struct. So if I try to change this one, something like this doesn't work, as you can see here, doesn't work. So if I try to change this one, y dot, what do we have, x, something like this, and let's change that one, this also doesn't work because it's read only. So ref read only is a very interesting thing. Now some of you might say, okay, that's fine, but there is a specialized keyword for that, isn't it? We could say in, yeah? So we do not need to say ref read only, right? That's the same? No, it's not the same. There is a tiny little difference between in and ref read only. In just suggests to the compiler, I would like to pass in a reference. But the compiler can decide. So the compiler can decide, no, I'm still using call by value. But if you say ref read only, you are forcing the compiler to do a call by reference. So you have both options. You can use in, you can use ref read only, but both are sometimes interesting and important features. Are we good? Yeah? Did anybody not know ref read only so far? Okay, you already learned something new. Awesome, amazing. Did you know that there is a read-only ref2? Did you know that there is a read-only ref read-only? You will learn about that in a few more minutes. Yeah.
Why would you force the compiler to do something? Maybe most of the time the compiler knows better than you.
I don't know. Sometimes the compiler is not nice to me, and then I want to force him in doing something because I simply want. No, I don't know. Sometimes you might want it because maybe the compiler optimizes something in a way that you don't know. But now you know what the difference is, and you can decide on your own. Maybe because of some optimization or some performance analysis, you find out that this would be beneficial. Then you can use it. Okay, good. I think we are pretty good. Let me see. So we have in, we have ref. Do you all know out? Yeah, out. Everybody knows out. We are not talking about out today because it's ref read only and ref everything and not out everything, whatever that might be. Okay, good. Let's get rid of that. Next one. Did you know that this exists? Int x equals 10. Ref int ref x equals ref x. Ref x equal 20 console write line x. Isn't that a thing of beauty? Many people don't know that this exists. Yeah, you can have a variable int on the stack, and then you can have a pointer, ref x, pointing to the same memory location on the stack, and you can manipulate the original value through a ref variable. And the result, well, obviously, it's pretty clear, is 20, because although we are changing ref x, the result of x is changed because it's a ref variable, right? So again, why would you do something like this? There is a really meaningful thing here. Imagine that you have a date only, which is the D1, and let's say this is a new 2025-11. That's fine. Then we have a D2, that's 2025, let's say 1201, and that's fine. And then I'm going to say the following: ref date only earlier equals to exactly that. And then print the earlier. See? By the way, I love writing C# code with cursor. Do you see? I'm using the cursor editor, and it's so great in completing my thoughts and sentences. It's really amazing. So take a look at this line here. This line does the following. It contains a ternary operator that simply checks whether D1 is smaller than D2. If D1 is the smaller one, then we are returning a ref D1. Otherwise, we are returning a ref D2. So at the end of the day, earlier will point to the earlier date of these two. And then, whenever I want to process the earlier date, I can simply access earlier. I do not need to copy anything. Understand? Makes sense? Question?
Why is there a ref at D1 but no ref at D2?
You mean where this ref here? Yeah. Okay, I get what you mean. So what we essentially write here is we say the entire thing is a ref, but you have to add another ref here. That's just a necessity. You can't write it like that. The compiler forces you to put the ref on every variable, and you must use the ref on the left-hand side too. So this ref is not pointing to this D1, but it's really the ref across the ref assigned to the entire expression. Make sense? But maybe somebody thought that this is very good to read. I don't know, but I can't just tell you it's a fact. You have to write it. It's just a fact. This is nice, but we can make it even nicer. Imagine that you have some numbers, okay? Numbers. And let's add a bunch of numbers. 1, 2, 3, 4, 5. Looks very good. Now, I would like to be able to access the second number. Absolutely no problem. Ref int second ref numbers 1. And with that, I get a pointer inside of the array pointing to the second number inside the array. And now I can manipulate the second value. I can say second plus equals 10, something like this. And then I can, again, print this thing. So if I run it, it should print 12 because through this ref int, we are manipulating this value through the ref int. Nice, isn't it? There definitely are applications for exactly that. That's simply a ref variable accessing something like this. Are we okay? Are we good? It's good that we now understand that there are ref variables, but in many cases, you do not want to use the ref variable directly inside your code. Often, you want to write some helper methods, for instance. Let's do the following, okay? Let's say we have a static date only, find earliest date, and we get in a date-only array of dates. Sounds very meaningful. And here we would like to simply add the earliest date. Please import. Come on. Thank you very much. On stage, I typically do not want to type code, so sometimes, yeah, I guess that this should just work. But what we can do here, the system said it's using a ref earliest. You see, it starts with a ref date 0. It walks through this thing, and then it returns the earliest. But you know what I can do, and that's the amazing stuff. I can put a ref here. I can put a ref date only here, and I can do a return ref earliest here. And now, this again is a thing of beauty, because now I have a method that looks through the array, and it doesn't return a copy of the earliest state, but it gives me a pointer to the earliest state. So the caller from outside can ask this method, give me a pointer to the earliest state because I need to apply some business logic to the earliest state. Maybe I need to manipulate it. Maybe I need to see whether this is a weekend and I need to calculate something or change it or whatever you want to do. Make sense? Yeah? Okay. So this is ref return. It's very simple to what we had before, but at the end of the day, it's useful in many cases, and I will show you examples in a second. So let's try this thing, okay? Date only, exactly, dates looks very good. And then we want to find the earliest date. Does this make sense? Yeah, it absolutely makes sense. Ref, date only, earliest, and now I'm using the ref again. The ref keyword here is required because this is a ref return, and as you learned before, caller and callee have to agree on that we want to use ref. The caller and the callee have to say, yes, I would like to use ref. So here we assign the ref return to a ref variable. And now we can, for instance, manipulate this thing. I can do something. I can say earliest, something like this. Or maybe change that one to 2024. I don't know why I should do that, but yeah, definitely it's possible. Does it make sense? Okay, amazing, amazing.
Sorry?
Yeah, question.
It's possible to return a ref read only?
You want to return what? You want to return a ref read only. I can't think of a reason. Why not? I've never tried it, but yes, it's possible, absolutely. I've never needed that, in fact. But it's possible. Yeah, yeah, good question.
Just to force it not to change. Just to
Exactly. I'm returning a pointer.
yeah.
I'm forcing the compiler to return a pointer. Yeah, absolutely. Why not? Yeah, yeah. Good question. Good question. Thank you very much. Okay. So let me quickly check my notes so that everything is fine. Exactly. Let's stick with this ref return for a second and build a very special base class, base infrastructure for the mostly cited game in the history of programming languages ever, tic-tac-toe. Let's implement a very simple tic-tac-toe board. Let's implement a struct tic-tac-toe board. That is fine. And we are receiving a character array, and this is the board. Okay? So we are using a primary constructor here. We are taking the board, and we can very easily new that up. Var board equals to new tic-tac-toe. That is good, but I do not want to do it like that. I would like to say var board data, and that is a new char and so on, and something like this, and passing the board data. That is good. So nothing special so far, right? However, now I'm going to say, let's make an indexer, public. And then I'm going to say char. Let's make an indexer, this. But in this case, I would not like to have an index from 0 to 8, but I would like to use a tuple with row and column. So I would like to have a data structure where I can index in the flattened array using a row and a column. The implementation is pretty obvious. I would like to have a read-only thingy here, so I'm going to do something like this. Pretty clear, nothing special, I'm okay with that. So if I would like to print something, I can do it like that. 0, 0 should become an X. Let's see if it works. Yeah, returns an X. It looks very nice. But now, I could do something else. Now I can say, you know what? Let's make this thing a ref. Let's ref return the board, and suddenly I can do something which is really amazing, and I'm not joking. This is a really nice design pattern. I can say, give me the board with index 0, 0, and I can write to this indexer. The indexer is now no longer copying out the value at the index 0, 0, but it's giving me a pointer to the element retrieved through that indexer. And now I have a read and write accessor with this ref return. See? I really like this pattern. This helps a lot. Personally, I know this pattern quite well because it's very, very often used in Rust. I am personally a big fan of Rust, and Rust does this all the time. But in C#, I rarely see this pattern, but it's useful. It's really, really useful. Question?
Why not you have to squeeze
I didn't understand it.
Why don't you have to like squeeze in the ref into the quality?
Why do I have to squeeze in? You mean that one?
No, on the quality. Why don't you have to put the ref there?
Because I'm not declaring a variable here in this case. I'm just using it. It poof goes away because I'm never instantiating something of type ref. So here on the left-hand side, I'm using the pointer to write something to the thing that comes back, but I'm not storing it. If I would store it, if I would say, okay, it automatically understands what I want to do. So it's AI, it's AI. Maybe it listened to your question and immediately tells you can do that. I mean, I think I can go, let cursor do the rest of the talk. I mean, so now you see it, right? Does this answer your question? You could say, why did they design it like that? I don't know. You have to ask Anders Heigsberg or whoever designed or invented this feature. Okay, are we good? What if we change that to read-only? Why does this still work? I can prove to you that it still works. Oh, we wrote it. Why does this still work?
The right-hand side is still a ref.
The what?
The right-hand side of the expression of line number 9.
Line number 9 is still a ref? Yeah, but I'm saying read-only. Ah, you meant I should do something like this? Yeah. Doesn't work. You cannot put read-only on the right-hand side. It doesn't work. The reason is something else. This read-only does not relate to the ref. Yes, I know, it's strange. But this read-only refers to the method and simply indicates to the C# compiler that this method implementation doesn't change the state of the struct. So this is a read-only method. Unfortunately, it looks like a read-only ref, but it isn't a read-only ref. It is a ref in a read-only method. Got it? Have you ever heard of read-only methods? It's fine. If you define a struct and you set read-only to a method, the method is not allowed to change anything inside the struct. And this is exactly what we do here. So we simply say, this is a read-only method, and it's returning a ref. It's a little bit confusing because, as I said, it looks like a read-only ref, but it isn't really a read-only ref. Yes?
So it's basically like a const method in C++.
If you say so. I've learned C++, but it's, I don't know, 25. I'm probably older than anybody here in this room. I learned C++ 30 years ago, but I stopped using C++ 28 years ago. So, yeah, it was a sin of my youth. And yes, I have to admit, because of the speaker in front of me, I used Silverlight. And it was the stupidest thing on earth I ever did. Yeah. Okay, I think it's fine. Let me quickly show you, so you really understand what this read-only is all about. Public, read-only, something like char get winner. Okay. This one, and please import. I'm too lazy to implement a get winner function on my own. I mean, why did anybody invent AI? Because AI can implement the get winner function in tic-tac-toe, right? So here you see what read-only is really all about. We have a method, get winner. This method is read-only because get winner is not changing any state inside the board. So this read-only has the same contextual meaning as this read-only up here. Are we good? Amazing. Amazing. Very good. So let's delete everything. So far, we didn't touch anything particularly new in C#. Now we want to approach the world of the new things. And the rather new things is a guy which is called read-only span of something or span of something. Span of int, something like this. Who doesn't know span? Okay, some. Some don't know span. Most of you know span. That's fine. So let's take a look what this span is all about. This span is, again, read-only ref. You know why I called it everything about C#? Everywhere ref. After this talk, you will only see ref in C#. Now, what is that? The read-only ref is not the important one. The ref struct is the important one. A ref struct is a struct that, listen closely, I'm choosing my words carefully, a ref struct is a struct that must live on the stack. It must never exit the stack and live on the heap. Never, never ever. Why? What's the advantage of a data type that must exist on the stack and only on the stack? Any idea? Yeah, Jonas?
It's faster.
It's faster, yes. Why?
Because the stack can't live on the heap.
You don't need a garbage collector, right? But it has a second property that again makes it faster. It's always thread safe. The thread is always assigned to a single thread. There is no way that somebody can access the stack of a foreign thread. If something like this happens, it's the end of the world as we know it, as C# developers. It must not happen, never. So if we have a ref struct, it's always thread safe. So there is absolutely no necessity to do anything related to locking. Suddenly as C# developers, we live in JavaScript land. Wow, everything is single-threaded. That's beautiful. I'm also a proud JavaScript developer, and from JavaScript I know that this is beautiful, a beautiful place to be. But here we are forced to live on the stack. That has advantages because, for instance, the span of int doesn't need to point to an array on the heap. We can say this is an int array, something like this. That is fine. That is just a different way of writing it. But you know what I can do? I can say stack alloc here. And if I say stack alloc, I have a ref struct on the stack, and this ref struct is pointing to an array on the stack. So this is stack only, no heap allocation at all. And the span is capable of doing that. So span is not just a thingy that lives on the stack and is thread safe, but it's also an abstraction layer for different types of memory. It's capable of pointing to the heap, it's capable of pointing to the stack, and it's also capable, I'll tell you a secret, to point on the unmanaged heap. So if you get something from the operating system, for instance, by doing an operating system call, and the operating system is placing some memory on the unmanaged heap, you can create a span, and the span can point to the unmanaged heap, and you can access this unmanaged heap through C# safely without needing to copy this thing out. And this is what makes C# fast. It reduces the amount of situations where you have to copy data in order to process it significantly. Think of a web server. You get from HTTP some headers and they live in the unmanaged heap. You get it directly from the operating system and you need to parse an HTTP header. In the past, you had to copy it out into a C# string and then work with it. Now, no longer the case. You simply create a span and everybody's happy. Understand what I mean? And this is the magic of this ref struct. So ref struct is a really powerful thing, and in this case, it's a read-only ref struct, meaning it lives on the stack and it cannot be changed. It's an immutable data structure. That is what read-only ref struct here means. This comes out of the box. And by the way, there is also a read-only span, which is also a read-only ref struct. The only thing, through the read-only ref struct, we cannot write to the underlying memory. So if I create a span and we take a look at the implementation, we will see somewhere, maybe if I can find it, span, to string, try copy to, operator, somewhere we will maybe find it. I can't find now, but through the span, I can really write to something. I can say something like this. If I have a read-only span, I cannot write to this element. Good? Yeah, I want to show you that. Give me a second. It can't be. I mean, let's take a look. Let's take a look. Where are we? Here, different browser, this one. Give me just 30 seconds and then we know it. Ref span of T C#. Come on, here we are. Where do we have our methods and our properties? Empty is an item. See? This is what I wanted to show you. Can you remember tic-tac-toe? Yeah, the thing that I showed you? There, you see Microsoft using exactly that pattern. This is a span. Span of T, which is just a pointer to an array that lives on the heap or on the stack or on the unmatched heap, has an accessor that allows me to use the index to get an element from the span, but I don't get a copy of the element, I get a ref of the element. So span, this thing that makes C# fast, is using the same technique as I showed you in tic-tac-toe. And if we take a look, not on span, but if we take a look on read-only span, then it cannot find this thing. Come on, give me read-only span of T C#. Good. Properties, item, and boom. Also returning a ref, but a ref read-only. And what did we learn about the ref read-only? You cannot write to it. And that's the difference between a span and a read-only span. Read-only span returns a ref read-only, span returns a ref. So you can write through it. Okay? Good? Amazing. Now, you know, the world would be such a great thing if span could do everything that an array can do, but we can't. Here we have a span, as you can see here. Can we do something like this? Object numbers object equals to object numbers. Doesn't work. Why? It's not an object. But you know what? When I learned C#, my teacher told me in C#, everything is compatible with object. That is no longer true, is it? Yeah. Exactly. Boxing was the key. Exactly. What happens here, for those of you who are not that deep in C#, something very interesting is going on. Now I'm doing something which is really, really dangerous. You know, I have no idea about Java. I'm not a Java guy. JVM is like Japanese for me. I have no idea. I find it fascinating to watch people write Java code, but I have no idea what they are doing or how this works. But I heard that in Java, everything is an object. Is that true? Can we say that? In Java, everything is an object? Everything is derived from object? Is that somewhat true in Java? At least people told me something like this. In C#, things are only compatible with object, but they aren't objects, because object is a class. And some things in C# are structs. And you cannot be both a struct or a class, because as a class, you live on the heap. As a struct, you live on the stack, right? So this thing does what Jonas just told us is boxing. So what it does, it takes the here, object, which is a struct, puts it into a nice little box, and puts it on the heap. This is what boxing does. For me, it's always easy to remember. I'm thinking of a Christmas tree. You know the presents, the heap of presents under the Christmas tree? If I want to put the present under the Christmas tree on this heap of presents, I have to put it in a nice little box. And that is how I remember boxing. So I take an object, put it in a nice little box, and put it under the Christmas tree. This is what's happening here. But this is a span. And what did I tell you about a span? It must not live on the heap. But if you put it in a box under the Christmas tree, it suddenly lives on the heap. So therefore, this is not allowed. I'm super sorry. Okay? So this must never, never, ever happen. It must not happen. And many other things are also not possible. Whenever you try to do something in C# that would implicitly put the span of T onto the heap, it's forbidden. And up until the latest versions of C#, the compiler was very, very strict. And the C# team said, if there is only a risk, if there would be some kind of niche scenarios where this thing would escape to the heap, we forbid it. And over the last few releases of C#, they thought hard about these limitations. And over the course of time, they started allowing certain situations where they found out, after thinking hard about it, that it might be a risk on the first view, but if they think about it closely, there is no risk, and therefore they allow it. One of the most important limitations of ref structs is that you cannot use them in asynchronous programming. Or you couldn't use them. Let's put it like that. Let me show you what I mean. I forgot to write down when we started. How long do we still have time?
I don't know.
15 minutes, something like this? Is that okay? Okay, I'm good. I will stick around, so if you have additional questions. I have a full day workshop about that. So if you want to stay until, not kidding, I did full day workshops on this topic. So if you want to stick around until tomorrow morning, we can do that. But I'll try to get it done, okay? So let's create a method, static async task of char, something like this, and say get tic-tac-toe board, something like this. Okay, let's await task delay 1000 and return something like this. Let's put this up here, and we are good. Please take a look at this method. I will zoom in a little bit. Here we are. And as you can see, this is get tic-tac-toe board. Imagine that we are reading the tic-tac-toe board from a database here, okay? So this task.delay, obviously you don't write that in your code, do you? Hopefully not. Well, we shouldn't. This task.delay is just a placeholder where you have to imagine calling a backend microservice, calling a database, using entity framework. Any async IO stuff is going on here. So this is just a placeholder, and then we have our tic-tac-toe board, which currently has a winner. Right? I think so. I think O is a winner, right? I'm not sure. It doesn't matter. Doesn't matter. Okay, now we have a database call. And now we would like to implement static async task use tic-tac-toe board. Do something like this. Okay, and here we get the tic-tac-toe board asynchronously. See? Now, this is the important one. You are the author of this method. You must use the get tic-tac-toe board because somebody else has written this method for you. Okay? It reads something from the database, and the author of this function has learned that it is a good thing to do async await when doing IO operations. Double thumbs up, this is what we should do, right? So here we are using task, tic-tac-toe board, whatever, and we are awaiting this method. Everything is fine. But you know what the problem is? Immediately, when you do something like this, and you use an older version of C#, you cannot use ref structs anymore. You cannot even use ref variables anymore. They are not allowed if a method is async await. And that means that many developers were locked out from benefiting from spans, from ref structs, from ref variables, because they used async await. It's so common to use async await. That is probably the reason why many of you haven't ever used span before, because you are async await. You are using async programming, obviously. But now this has changed. So what we can now do is we can copy our good old tic-tac-toe board again, and I have implemented that. I've prepared that. Can you remember? This is the one that we implemented before. It's the tic-tac-toe board, see? And this is with the ref jar and so on. You can remember what you did here, right? I simply don't want it to impress you by AI. I copied it in. This was my AI. Yeah. Now back to async. Now I read the tic-tac-toe board, which gives me a character array, and from this tic-tac-toe board, I can now create the real tic-tac-toe board. Here it is. Now let's imagine that we have certain operations. Let's change our tic-tac-toe board a little bit. Let's change this one to not having a winner. So let's change this one. Come on, AI. Come on, AI. Okay. If you want me to do it manually, I will do it manually. Okay, so we have an empty board, and now maybe let's create some moves. These moves are an array, and let's create tuples where we say 0, 0, and we set the x. And okay, let's agree. Let's agree to that. And now we would like to apply these moves to the tic-tac-toe board, okay? So let's do that one. We go through the moves, and we would like to apply these moves on the board. So let's first grab the field. Ref var field equals to ref ttt board with row and column as a tuple on this. And see, that is the magic thingy here. That is C#13. This is why C#13 is so amazing. This wouldn't be possible in C#12. We couldn't do it. That's a simple ref variable. I don't even need to use a span here. Only using this ref thing here, what we have here, isn't possible in C#12, but it is possible in C#13. Now, this is only possible in C#13. And I can prove to you that this is only possible in C#13 because I've prepared a .NET Fiddle here. And here you see, this is .NET 8, see? And if I would like to compile that, the system gives me an error in line 43 telling me that ref is not allowed in async await. And if I change that to .NET 9, the system removes my entire code, obviously, right? Of course. I mean, what else? Okay, that's, I copied a little bit too much. So, and you see, there is no longer an error. So this is an important new step in C#13, and now you know why. You've learned about ref variables, about this ref indexer. We heard about ref structs, and this is really a big thing, that this is now possible. So let's do the rest here. Where are we? Exactly. Now here we have the field, and now we can say field equals player, and maybe we do, just for demonstration purposes, a task.delay again, and at the end we, I don't know, what else? We print the winner. That sounds okay. So we can now here say use TTT board instead of get TTT board, and it will work. It will compile, we don't have an error, we use ref, everything is fine. Are we good? Really nice, isn't it? Big, big advantage of C#13. An advantage which is not that obvious. This is what I mean with a hidden hero. Ref structs make C# faster. These ref indexer make designs sometimes more beautiful. And now these hero can be used in more situations than in the past. We had a similar problem when we were using iterators before. So if I get rid of this use TTT board, no, not get rid of it, but I keep it, and I say, I don't know, static I enumerable of bool, it returns after every move whether we already have a winner, okay, just for demonstration purposes. Apply moves, and we get the char array, which is the board, and then we get some moves. We get exactly that. Okay? What do? first, we grab the tic-tac-toe board, which is TTT equals to new tic-tac-toe board. That is good. And then we simply walk through the different things. You see, ref var field, field equals player, yield return whether we have a winner. And again, this is now possible. Wasn't possible before. Yes?
Does this enable link view for spans?
No. Link, for a very good question, is link enabled for spans? No. Because in order for link to work, you need to implement IEnumerable because link is implemented as extension methods on IEnumerable. You know that. And span does not implement IEnumerable. And therefore, link is not enabled. It doesn't work. You can for each, that's fine, because that's an interesting one, Jonas. That's an interesting one. Because who knows what I mean with duck typing? Nobody? Maybe? Yeah? Quack, quack, quack. What am I?
It's the reason why polyfill.net works. Like there's this extension, there's a NuGet package
Yeah?
that you install
Yeah?
into .NET 4.0 projects, and suddenly all the new language features work.
Yeah, might happen. But let me describe what duck typing is. If I stand here and say quack, 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 what am I? You might say a duck, right? But trust me, I'm a human. Okay, I'm not a duck. But why did you say I'm a duck? Because I sound like a duck, I walk like a duck. Let's call it a duck. That's duck typing, okay? And many people say, oh, duck typing. Duck typing, this is something for the TypeScript world. Ugh. In C#, we have strict types. We don't do something, walks like a duck, talks like a duck, call it a duck. This is something that real programmers in C# don't do, right? No, you do it. Span of T, C#. Span of T, trust me, it doesn't implement any interfaces, right? Yeah, everything's fine, right? But if I take a look at methods, there is a method which is called getEnumerator. And because there is a method which is called getEnumerator, you can for each over a span. Duck typing. For each, many think that for each requires an IEnumerable in order to iterate over an object. Not true. For each only needs a duck. If it sounds like a duck, if it walks like a duck, we can iterate over it. If it has a getEnumerator method with this signature, fine, let's enumerate over it. Understood? So this is the reason why, Jonas, for each works. I know you know that, so, but yeah. This is the reason why for each works, but link doesn't work like that. Because link is not based on duck typing. Yeah, it would be nice. And I think if the guys at Microsoft would reinvent C# nowadays, they would probably rethink the IEnumerable design, because it maybe was not the best idea at the very beginning. Yeah, but it will never change, because if you change that, you can invent a new programming language. And you can use Rust, because there is only already a programming language which does that perfectly. Yeah, good. And last but not least, and then I think we should come to an end, my final sample, and that is also a very interesting one, because I would like to implement a ref struct. Let's define a ref struct, and this ref struct should be a vector, which is a two-dimensional vector, and it has a float, that's enough, float x and float y. I think this is pretty good, so this is, I think, okay. Let's do that. Let's make the fields available. Public float x equals x, and public float y equals y. Looks very good. And now I would like to be able to add vectors. Add vector. Come on. Add vectors. Yeah, thank you very much. Isn't AI wonderful? You simply type what you mean and you press space and the thing does whatever you want. Looks pretty good. You see you have an operator, but in this case, I really don't want to implement an operator. I just want to say add. add is fine. So we have a static method returning a vector 2D, gets two vectors, and the new vector simply adds the x's and the y's. So I think this is pretty good. This is nothing special. We had that before, so I think this would be okay. But now in C# 13, we can do something which is pretty amazing. We can make an interface, I_addable of t, something like this, and then we can say, okay, we need a static class. Let's make it abstract. We have abstract members in interfaces for quite a while now, and we do something like this. So would it be possible to simply say ref struct implements I_addable? No. This has been a limitation of ref structs. Ref structs cannot implement interfaces, right? But now in C# 13, they can. What you can now do is you can go to the interface, here in the interface, and you can simply say, we allow where t allows ref struct, and suddenly this stuff works. Yeah? So what you can do is you have to say this type t should allow ref structs. By doing that, you are agreeing to a bunch of limitations related to that interface. And I do not know the limitations from the top of my mind. If I do something with this interface which isn't allowed, the compiler will probably shout at me. So I don't have from the top of my mind all the limitations that you get when you add this possibility, but for our work, this is amazing. This is really amazing because now we can do great stuff, right? Let me think of an example so that you see that this stuff really works. So let's say vector 2D v1 equals to something like this, and then add these two things and then print it. Exactly. And let's print, come on. Come on. Thank you very much. Sometimes you just have to ask nicely. Okay, and you see, adding works like a charm. Now some people might say, if that works, can we say var vector 2D as I_addable of vector 2D? No, this still doesn't work. Because if you do this typecast, this would lead to escaping the ref struct to the heap, and therefore it's not allowed. So you can implement interfaces, but you can't use these interfaces like that. That is simply not allowed. So what's the advantage of having interfaces? The advantage of having interfaces is something like this. I will copy that in because I have nothing new to tell you. This is an interface. I have length. Okay. And then we have something like this, an aggregator. And this aggregator is capable of aggregating items that implement I have length, and it allows a ref struct. Okay? So what I can do is I can go up here and make this vector not only an I_addable, but I have length. Obviously, we have to implement the length now. And this thing works. This thing is now capable of processing items which might be ref structs, but must be I have length. Understood? So this aggregator accepts items, they must have a length, and they might have a ref struct. So the aggregator can aggregate instances of a vector 2D because of the interface I have length. So I could implement this generic aggregator, whoops, in C#13, which I couldn't have implemented in C#12, because in C#12 there would be no possibility to implement I have length on my vector 2D. Understood? Question?
It doesn't guarantee that it's a struct. It just allows it. So you can
It allows to be a ref struct.
Objects or ref
Yeah,
structs.
yeah, exactly. Yeah.
So you
Absolutely.
can't guarantee that it's never something that's copied in there, so because it can be an object as well.
Exactly. And the C# compiler will take a look at the concrete type and decide how to deal with it. Yeah, exactly. So what I wanted to show you in this short little talk is I wanted to remind you that you have this cute little keyword called ref. And we started very slowly by repeating this ref parameters. Everybody knew it. Everybody thought, oh, this will be a boring talk. And then I showed you some things which are pretty old, like ref read-only and things like that, which are still not known to everybody. And then we worked our way up to more complicated scenarios like ref structs. We saw that span and read-only span are ref structs, and they make C# significantly faster, or they made C# significantly faster. And I closed in the last 15 minutes or so by showing you 3 new features in C#13, namely the ability to use ref in async functions, the ability to use ref in iterator functions, and the ability of ref structs to implement interfaces, which made the ref keyword more usable. You can use it now in a broader amount of scenarios. And that's the beauty that came with C#13. And we can hope for that C#14 will add an additional number of features related to ref. I've already seen some features coming around the corner related to ref. So ref will stay as an important part of the underpinning of C# for being such a great language as it is. I hope this talk was a little bit interesting, and again, sorry for me being late. I hope it was fine for you. I hope it paid off to wait a little bit longer. I will stay around for a few more, for a little bit, but please understand if I don't stay until midnight, because I want to see how my cat and my wife are. So thank you very much for listening to me. Thank you for having me. Thank you for organizing. It was a blast.
Yeah, thank you very much, Rainer. Honestly, you did not lie when you said like ref everything. Oh boy. Yeah, that's it with the kind of official part with the talk. Please, again, give a big round of applause to Rainer for that really amazing talk. Just as a short reminder, our next meetup will happen on the 24th of April. We will be at our friends at Cloudflight. You will find all our dates and also the recording of the talk from today online on our different kind of platforms. So make sure to stay connected with us. And if our host is not throwing us out of the door, I saw there's still cake left, there's still beer left. So stick around, ask some more questions to Rainer. Thank you very much for coming. Danke.